with the help of call by reference implementation. Okay, so now we'll discuss about concept of recursion in functions. So what is meant by recursion? Recursion means function calling itself is called as recursion. Okay, so let me explain here what is meant by recursion. So recursion means function calling itself. Calling itself is called recursion. Okay, so in this recursion we can classify the entire concept of recursion into two types. One is direct recursion, the other one is indirect recursion. Okay, direct, the other one is indirect recursion. So if you consider direct recursion, okay, so an example for direct recursion implementation will be like this. First of all, you will be implementing function f, okay, and within the same function you are going to call the same function, okay, which is basically concept of recursion. Okay, is directly an example for direct recursion. Now if you consider indirect recursion, this will work like this. Function f implementation is done, okay, which is a recursive implementation. Function f is going to call function g. Function g is going to call function f, just like this. Okay, so if you consider indirect recursion, f is calling function g and g is calling function f. Okay, this is a type of indirect recursion. So now in any recursive call, okay, in any recursion, there are two main components of recursion. One is base condition, second one is recursive call. Okay, base condition and recursive call. So if you observe the base condition, this is going to act as a terminating condition. Okay, considered as terminating condition. And if you observe the recursive call, this is to proceed to the next function call. Okay, so next function call is implemented with the help of recursive call. Okay, like this. Now what happens when the base condition is incorrect? Okay, so whenever the base condition is incorrect, the program enters into infinite recursive calls. Okay, so generally the concept of recursion is supported by a data structure called stack. Okay, recursion is supported by stack data structure. Okay, remember this. So recursion is implemented or supported by a data structure called stack. So whenever a function is called, immediately its corresponding information that is kept inside an activation record will be pushed inside the stack. So the moment function execution ends, its corresponding activation record will be popped out from the stack. Okay, so now the moment you write an incorrect base condition, okay, so immediately what happens is that the stack becomes overflow. Okay, any incorrect base condition will leads to stack overflow. because this recursive calling process will not end, and recursively the same function is called again and again. It will lead to more and more push operations into the stack, and always stack will have a limited size. The moment it reaches beyond the maximum or capacity of the stack, this is going to produce stack overflow. Okay, so now let's consider an example for recursion. Okay, so the best example for recursion is factorial program. Okay, so that we will discuss right now. So in a factorial program, okay, suppose I want to compute factorial of 4. Okay, so if you understand the iterative method, in iterative method, the factor of 4 can be computed as 4 into 3 into 2 into 1. Whereas now we are looking into the recursive method. In the recursive method, it is implemented as 4 into 3 factorial. Okay. Again, 3 factorial is implemented as 3 into 2 factorial. Okay, like this. So you can see here 3 into, okay, basically 4 factorial is 4 into factor of 3. Okay, so I can say mathematically 4 factorial is nothing but 4 into 3 factorial. Okay, and then 3 factorial is nothing but 3 into 2 factorial. So 2 factorial is nothing but 2 into 1 factorial. Okay, suppose 1 factorial value is taken as a base condition. Okay, so in that case it is going to return 1, and then 2 into 1 is 2, so this value of 2 is returned back. Now 3 into 2 is 6, 6 is returned back, and 6 into 4, okay, this is going to give you the value as 24. This is how we can compute 4 factorial, isn't it? So now 4 into factor of 3, which means here the same 4 into factor of 3, this factor of 3 can be computed as 3 into factor of 2. So now this factor of 2 can be computed as 2 into factor of 1. And finally this factor of 1 is computed as 1. Okay. So you can observe here 1 is returned back to the calling function. Okay. 2 into 1 is given as 2. Now 2 is returned back to the calling function. 3 into 2, 6. Now factor of 3 is returned as 6. So 6 into 4 is 24. Yes or no? Clear? Like this. This is how we can compute factorial of 4 using recursion. Okay. So let's implement this particular recursive function in order to execute this factor of 4, for example. So let's consider the header file first. Hash include std io.h. Okay. So inside the main function we are going to call, okay, but let's implement the fact recursive function first. So return type of the fact is integer, and it is taking parameter as variable n. Okay. So now you can see here the condition is if n value is double equal to 1, okay, n is double equal to 1, we can return 1. Return 1. In the else case, it can return n into fact of n minus 1. N into fact of n minus 1. Okay, so now we'll consider a main function. In the main function, we are basically calling this fact function. So this is printf percentage %d. Let us suppose it is calling fact of 3, for example, directly. Okay, so let's consider this example. Okay, it is simply calling fact function by passing parameter as 3. So let's see how this is going to be evaluated. Okay, so the moment fact of 3 is called, so immediately the value of 3 will be passed and it is stored inside a variable called n. Okay, so now n value is 3. For this recursive call of n is equal to 3, okay, n equal to 3, n double equal to 1, 3 double equal to 1, condition true or false? Condition becomes false. Now it will go to the else block. So in the else block, it is going to execute 3 into fact of 3 minus 1, which is nothing but fact of 2. Okay. So now let's see how this fact of 2 is going to be executed. Okay. So 2 double equal to 1, condition true or false. In this case, you can see n is equal to 2. Okay. 2 double equal to 1, condition becomes false. So it will go to the else block and it is going to execute n into fact of n minus 1. So that is 2 into fact of 2 minus 1, fact of 1. Okay. So in this recursive call, you can see n is equal to 1. Okay. Since n is 1, in this particular recursive call, you can observe 1 double equal to 1, condition becomes true. So for n equal to 1, you can see 1 double equal to 1, condition true, and it is going to return value of 1. Okay. So value of 1 is basically returned back to the calling function. When value of 1 is returned back to the calling function, 2 into 1 value becomes 2. Now the value of 2 is returned back to the calling function. So 3 into 2 will be 6. And the value of 6 is returned back to the calling function. Okay. So that is where this fact of 3 is called. You can see the output printed will be 6. Okay. Clear? Like this. So this is how, factorial program using recursion is getting executed. Okay. So now we'll consider another example clearly. So the next example is Fibonacci sequence example. Okay. So we need to implement Fibonacci sequence using recursion. Okay. So let's see how we can implement Fibonacci sequence using recursion. Is that fib of, okay, is a Fibonacci sequence. You can see in Fibonacci sequence, it is progressed like this: 0, 1, and the third term will be 1 because 0 plus 1 is 1, and the fourth term is 1 plus 1, value will be 2, and the fifth term is 1 plus 2, value will be 3, and the next term is 2 plus 3, value is 5, and the next term is 5 plus 3 equal to 8, and the next term is 5 plus 8 is equal to 13, and so on like this. Okay. So if you observe here clearly, Fibonacci sequence, let us suppose n, okay, fib of n. So it is going to return value of 0, okay, if n is 0, okay, zeroth term is 0, right? And next it is going to return 1 if n is equal to 1, and it is going to return previous sum of previous two terms, which is fib of n minus 1 plus fib of n minus 2 here. Okay, so we can consider this as otherwise. Clear? Like this. So based on this, let's implement Fibonacci sequence corresponding program. Okay, so first include the respective header file. Okay, so after including the header file, you can see here fib function, that is a return type of fib is integer. Now the parameter of fib is variable n. Okay, if n value is equal to 0, okay, so in that case we are going to return 0, return 0. Else if n double equal to 1, now we can return 1. Okay, return 1. Finally, you can see if this is not the case, then else return. So you can observe here clearly fib of n minus 1 plus fib of n minus 2. Okay, so we can write like this: fib of n minus 1 plus fib of n minus 2. Okay, so now we can actually write the main function, and simply we can call this fib function. Okay, recursive function. So you can see here printf %d. Okay, so let us suppose I'm going to call fib of 3. Let us suppose. Okay, so let's see how this fib of 3 is going to be expanded here. Okay, so the moment fib of 3 is called, its corresponding n value becomes 3. Yes or no? N value is going to be 3. So when n value is 3, it is going to be evaluated as fib of 3 minus 1. Okay, so this is going to be fib of 3 minus 1 is 2 plus fib of 3 minus 2 will be 1. So which is nothing but fib of 1. Okay, so now fib of 2 needs to be executed. When fib of 2 needs to be executed, you can see here this is fib of 1 plus fib of 2 minus 2 is 0, fib of 0. Okay, now you can observe here fib of 1. What is fib of 1? Okay, so fib of 1 is evaluated as n equal to 1, so it is going to return 1. So fib of 0, you can see n value is 0, it is going to return 0. And also fib of 1, it is going to return 1. Okay, so when the values are getting returned like this, okay, what is fib of 1? 1. So this is going to be evaluated as 1 plus 0 equal to 1. Okay, and what is this fib of 2? Fib of 2 becomes 1. Okay, and what is this fib of 1? Again 1. So fib of 3 is computed as 1 plus 1 is equal to 2, like this. Okay, so finally the output that is going to be displayed here is 2. Okay, because only when it encounters fib of 0 or fib of 1, it is going to return the respective values, like return 0, return 1, like that. Okay, so now we'll move to the next example on recursion. Okay, so we can calculate GCD program. Okay, that is greatest common divisor among two given numbers with the help of recursion. Okay, so according to this GCD concept, you can see GCD of A comma B is it is going to return B if B is able to divide A. Okay, and then this is going to return GCD of B comma A mod B if it is not the case. Okay, so let's see how this is going to return. Is that first header file, I've included the header file, and next GCD is the name of the function I'm using, and now it takes two parameters, int A comma int B. These are the two parameters used by GCD function. Okay, now if you understand this, B is able to divide A. In that case, it is going to return B. So which means if B mod A double equal to 0, then only we can say it is able to divide. B divides A. Okay, so now it is going to return a value called B. Okay, so basically here when B divides A means we have to write A mod B. Yes or no? So A mod B double equal to 0. In that case, we'll return B value. Okay. And next, GCD of B comma A mod B. We are going to call this if it is not the case. So in the else case, we can actually return B comma A mod B. Okay, which is we are calling the GCD function again by passing B comma A mod B. Okay, so just like this. So now in the main function, we can simply call this particular GCD function. Okay, suppose in the printf statement, okay, I'm just calling printf %d, okay, GCD of 12 comma 18. Okay, like this. So if you observe this function call here, okay, GCD of 12 comma 18, we are calling a function called GCD by passing the parameters 12 and 18, right? Now the A value becomes 12 and B value becomes 18. Okay, so you can see here this corresponding function call will be executed like this: 12 mod 18 double equal to 0, condition becomes false, so it will go to the else case, and this is going to call GCD of B. So what is B value? B is 18, comma A mod B, 12 mod 18 will be 12. Okay, 12 mod 18 is 12. So now the current GCD recursive call needs to be implemented. So this is going to be A value is 18 and B value will be 12 here. Okay, so now A mod B double equal to 0. Okay, that is 18 mod 12 double equal to 0. So condition becomes false, right? So this time this is going to call GCD of, similarly, okay, B value is clearly 12, comma A mod B. Okay, 18 mod 12 will be 6. So let's see the execution of this one, because now A is equal to 12 and B is equal to 6. Okay. So in the next recursive call, A mod B double equal to 0, 12 mod 6 double equal to 0, condition true. Hence it is going to return value of B. So value of B will be how much? 6. So value of 6 is returned, and now in the output this is going to display value of 6. So clearly you can see if the numbers are 12 and 18, what is the greatest common divisor between these two numbers? 6 is going to divide this for 2 times, and 6 is going to divide this for 3 times. So the greatest common divisor is basically 6 here. So that is the output produced. Okay, just like this. Next one, consider exponentiation operation. So we need to implement this exponentiation operation. So first all we need to implement is exp function, which is a recursive function. In this recursive function, if at all y value is 0, then it has to return 1. Okay, if this is not the case, then it has to return x into exp of x power y minus 1. Okay, so let's implement this one clearly. Okay, first include the respective header file, that is stdio.h. Okay, so now implement exp function, that is int exp of, okay, there are two parameters, one is x and one is y. Int x comma int y. Okay, so if the value of y is 0, if y double equal to 0, in that case we have to return value of 1. Okay, return 1. In the else case, we need to return x into exp of x power y minus 1. So let's return like this, return of x into exp of x power y minus 1. The first parameter can be x, okay, and the next parameter is y minus 1. Okay, like this. So we need to include a semicolon here. Okay, yeah, and then now in the main function, okay, so we are going to call here in the main function, just consider calling this function %d. exp is the name of the function. I am calling and passing 2 comma 3 here. So what is 2 comma 3, which is 2 power 3, yes or no? So let's see how this 2 power 3 is going to be executed. exp of 2 comma 3. Okay, so exp of 2 comma 3 can be written as x equal to 2 and y is equal to 3. So y double equal to 0, 3 double equal to 0, condition becomes false. Okay, so then immediately it will go into the else block. In the else block you can see x into, okay, exp of x comma y minus 1. X value is 2 and y value is 3 minus 1, value will be 2. Okay, so now let's see implementation of this exp of 2 comma 2. Now in the next recursive call, x value becomes 2. Okay, so this x value is nothing but 2, right? 2 into. Okay, so similarly this is going to be evaluated as 2 into exp of again 2 comma 2 minus 1, which is 2 comma 1. Now exp of 2 comma 1. So again y value is not 0. Here value of y is 1. So it will go to the else and perform 2 into exp of 2 comma 0. Okay, So in this recursive call, you can clearly observe value of x is still 2 and value of y is 0. Since the value of y is 0, it is going to return 1. Okay, it is going to return 1. So this is nothing but 2 into 1, value will be 2. Now value of 2 will be returned back to the calling function. So 2 into 2 will be 4. And now value of 4 is returned back to the calling function. 2 into 4 is equal to 8. Okay. So this is how it is going to return the value, which is 8. Okay. So very simple, the output produced will be 8, and exp of 2 comma 3, 2 power 3 is nothing but 8, right? So the same value we have produced, and the entire implementation of exp is done with the help of recursion. Okay, so now we'll discuss about storage classes in C. Okay, so how many storage classes are there? Totally there are 4 storage classes available in C. Okay, so the concept came based on the storage area where these variables are getting stored. At the same time, there are other constraints like what is the scope and lifetime of accessing those variables, and so on like this. Okay, so we'll be discussing in detail about all these things. So storage classes. There are totally 4 storage classes in C. Okay, those 4 storage classes are automatic storage class, second one is static storage class, third one is external storage class, and fourth one is register storage class. Okay, so these are the 4 different storage classes available in C. So in each of these storage classes, we will be discussing about these things, like what is the storage area. Okay, and what is the keyword used to represent that particular storage class. Also, what is the default value of variable that is created under this storage class? Default value. What is the scope of this storage class? And next, what is the lifetime? Okay, so basically these things we are going to discuss in each of these storage classes. Okay, so let's start our discussion here. First, starting with automatic storage class. Okay, in the automatic storage class, first one is what is the storage area for this automatic storage class. Okay, next one is what is the keyword used for representing automatic storage class variable. And the third one is what is the default value, okay, of this variable under this storage class. And fourth and fifth is scope and lifetime. Okay, scope, lifetime. Okay, so first remember the corresponding storage area for automatic storage class is memory, main memory. Okay, so it is main memory. And next, what is the keyword used for automatic storage class? The keyword used for automatic storage class is auto. Auto is the corresponding keyword used. Okay. Next, what is the default value under the variables which are declared under automatic storage class? So the default value is a garbage value. Okay. Default value is garbage value. So what is the scope and lifetime of this automatic storage class variable? Okay. So scope of the variable under automatic storage class will be limited within the function in which it is defined. Okay. And the lifetime. So the lifetime of such automatic variables are confined within the function. So the moment control comes out of this function, you cannot access those variables. Okay, you cannot access those variables. Okay, so that is why scope and lifetime of such automatic storage class variables are confined within the function. Okay, limited within the function. So now let me explain with an example the automatic storage class. So any storage class variables can be defined with a syntax like this. Okay. So what is the corresponding syntax used? So syntax used is first storage class. Okay. We are going to write storage class. So after mentioning the storage class, now space data type and then variable name. Okay. So these are the this is the entire syntax. Okay. Storage class, data type, variable name. Now, if we consider an example here for automatic storage class variable, we can write like this. The keyword used is auto for storage class representation, and data type, let us suppose int is a data type and variable is a. Okay, so this is auto int a, isn't it? Similarly, when you want to declare multiple variables, okay, suppose you want to define multiple variables under floating point data type, so auto float x comma y comma z semicolon, like this. So this is how we can write variables under a automatic storage class. Okay, so now let's consider a small program related to automatic storage class. First, include the header file. So after including the header file, now we can actually make use of the main function itself. Okay. So in the main function, suppose if I write auto int a, okay, and if I print value of a, print a is equal to, okay, like this. So then what is the output that is going to be displayed here? Okay. So if you consider this particular program, you can observe this is automatic storage class variable. Even if you don't write auto here, by default, the variables which are declared within the function comes under automatic storage class. Okay. So even if you don't write this auto, okay, it comes under automatic storage class because the variables which are defined within the main function or any function, by default, if you don't specify the storage class name, it comes under automatic storage class. Okay. So this is going to give you a garbage value. okay, a is equal to value of a will be some garbage value, okay, because the default value of a is a garbage value where a is under automatic storage class, okay, like this. Now we'll consider another example. Include stdio.h. Now let's consider a variable like okay, consider a function, for example function fun. So inside this function fun we are considering a automatic storage class variable. So you can write directly auto int a is equal to 10, okay, then a plus plus, okay, and then printf percentage d slash t a. Now we can write the main function here. So in the main function, let's consider okay, calling this particular function fun for multiple times, like fun is called for the first time, and then fun is called for the second time, and then fun is called for the third time, like this. So this is a code. Then what is the corresponding output produced by this particular program? Okay, so in order to see what is the output produced by this particular code, so first of all, main function is calling a function called fun, okay. So every time when function fun is called, it is creating an automatic storage class integer variable a whose value is 10, okay. So this is simply creating a variable a and its value is initialized to 10. Then coming to a plus plus. So value of a is incremented by 1. Yes or no? Value of a is incremented by 1. And you can observe value of a is modified to 11 here. Okay. So this time value of a is updated to 11 because a plus plus. And then it is printing value of a. It means the output will be 11. So control comes back to the main function and it is calling fun another time. So when you're calling function fun another time, again this statement is going to create a new variable which is a and its value will be 10. Okay. So after creating variable a and its value is 10, now a plus plus value of a will be incremented by 1. So which means this a value is clearly modified to 11. Okay. So now printing value of a will be 11. So then control comes back to the main function and function fun is called. So now calling function fun, again it is going to create a new variable. Okay. For the third time you can see it is creating a new variable a. Okay. And its value is initialized to 10. A plus plus. So a value will be updated to how much? 11. And printing a again 11. Okay. So you can clearly see here okay, every time when you are calling the function fun, it is creating a memory for a variable called a. Okay. And once the function is completed, okay, once the control comes out of the function, immediately the memory allocated for variable a will be deallocated. Okay. So what is the creation point of memory for variable a? This is the creation point, and the moment control comes out of this, immediately memory allocated for variable a will be destroyed. Okay. So this is how automatic storage class works, and hence it is producing the same output no matter how many times you are calling the same function. Okay. So now We'll discuss similarly about the second storage class. First one is covered. Now we'll discuss about second one. Okay. So the second one is static storage class. Now, even in this static storage class, we need to discuss about what is the storage area. What is the storage area? Okay. And what is the keyword used? Okay. Keyword used. And also, what is the default value? And also, what is the scope and lifetime of such variables under static storage class? Okay. Lifetime. Okay. So first one is storage area. If you consider static storage class, the variables which are declared under static storage class will be stored in main memory. Okay. So storage area is written as main memory. And what is the keyword used for static storage class? So the keyword used for static storage class will be static itself. Okay. Static is the corresponding keyword. And what is the default value in this static storage class? The default value, when you do not initialize the variable, its default value will be 0. Okay. 0 is the default value. Now, what is the scope and lifetime of the static storage class variable? So, if you consider the scope of this static storage class variable, it is again confined within the function in which we have defined this static storage class variable. So if you consider the lifetime, it is accessible throughout the program and the value gets persists across the function calls as well. Okay. So even across function calls, the value will be live. Okay. You will be able to access that particular value. Okay. So clearly that is the meaning of scope and lifetime. Now we'll see an example for static storage class. Here, first include the header file. Now consider static storage class variable here. Okay, like this, static int x, and the value of x is undefined here. Okay, and when you are trying to print a value of x like this, so then what is the output? Okay, so static int x, x is under static storage class. So what is the default value of the variable under static storage class? So the default value is 0. Yes or no? The variables which are defined under static storage class, default value will be 0. So the output produced will be 0, like this. Okay. So now we'll see related to accessing the values across the function calls example. Okay. So first include the header file, and then we'll write the similar function, okay, which is function fun that we have already discussed previously for automatic storage class. So in the function fun, we'll consider a static storage class variable. Static int a is equal to 10. Okay. So now it is performing a plus plus, and then it is printing value of a, printing %d a. Okay, like this. Now in the main function we can call this function fun. Yes or no? Function fun can be called multiple times like this. Three times. Okay. Now, first time when function fun is called, you can see this block of statements will be executed. Okay. So static int a is equal to 10. This is going to create memory location for variable a. Okay. And remember the static storage class variable. Okay. Once the memory is allocated, then every time it is going to refer the same memory location. And one most important thing is static storage class variables are initialized only once. Okay, are initialized only once. So only for the first time execution of this particular statement is going to initialize variable a and its corresponding value to 10. Okay, so later you can see a plus plus, which means the current value of a is modified to 11. Then it is printing value of a. So what is the output here? In the output you can see value of a is 11. Then control comes back to the main function and it is calling another time function fun. So function fun is getting executed. Now execution of this particular statement will not have any effect. Okay, so because the value of a is currently 11 and execution of this particular statement will not have any effect as this variable is under static storage class. Static storage class variables are initialized only once. Okay, so now writing a plus plus, it is going to increment value of a by 1, so this becomes 12. Now it is going to print value of a. Value of a is 12. Okay. Now next time control comes back to the main function and it is calling function fun. So calling function fun, this time you can see a value, current value of a is clearly 12. Okay. So a value is not going to be updated because execution of this particular statement will not have any effect. Okay, because static storage class variables are initialized only once. So calling a plus plus will increment value of a by 1. So value of a will become 13. Okay. So now a, what is the value of a here? You can see 13 is the updated value of a. So this is the corresponding output. 11, 12, 13. This is the output. Okay. So this is about static storage class. Now coming to the third one is external storage class. Okay, so similarly we'll discuss about external storage class. So the concept of external storage class is similar to the concept of global variables. Okay, because all the global variables will be considered as residing in the external storage class by default. Okay, so what is the initial value of this external storage class? Okay, you can see all the elements that we are going to focus on now is for external storage class. What is the corresponding keyword used? What is the memory location or okay, memory area or storage area? Okay, so next one is what is the keyword used? And next one is what is the default value or initial value? And next one is scope and lifetime. This is scope and similarly this is lifetime. Okay, so now let's see what is the corresponding memory area for external storage class. Okay, so it will be main memory. It will be main memory only. Okay. So what is the keyword used for external storage class? So when you are declaring variables at the global declaration section, by default, you don't need to specify the corresponding storage class. They come under external storage class. Okay. So the keyword used is extern. Extern is the keyword used. Next, what is the default value of this external storage class? So default value of external storage class will be 0. Okay, default value is 0. Now what is the scope and what is the lifetime? Scope is these global variables or external storage class variables are accessible in the entire program. Every function will be able to access these external storage class variables. Okay, so and then coming to the lifetime, so till the program execution ends. Okay, till the program execution ends, you can access those external storage class variables. Lifetime persists till program ends. Okay, so now we'll discuss an example program related to external storage class here. For example, include the header file. Okay, and int x. So in the main function, we are trying to print value of x here. Okay, so when we print value of x percentage d x, what is the output that is going to be displayed? Okay, for this particular program. So this type of programs are useful in aptitude questions. Okay, C programming aptitude questions. So this is clearly under external storage class. Okay, so whether you specify the keyword extern in front of it or not, by default you can see this variable declaration is in external storage class as this is defined in the global declaration section. And since this is commonly accessible by each and every function, okay, and also one more thing is variable x default value is 0 because it is under global variable, or we can say this is under external storage class. Default value or initial value of external storage class is 0. So when you have not defined value of x, so in that case you can see value of x will be simply 0. Okay, like this. So now I'll give you one more example to illustrate this concept of external storage class. So again you can take here int a is equal to 3, b is equal to 2. Okay, so you can write multiple functions like function f1. Okay, here you can print value of a and b, percentage d slash t, percentage d slash n, a comma b. Okay, and now similarly in the function f2 also you can print, so that is printf percentage d slash t, percentage d slash n, a comma b. Okay, so finally in the main function you can actually call these two functions like function f1 and function f2. Okay, so this is going to call the function f1, and the function f1 will be able to access those variables a and b. Okay, so this particular statement that is defined in the global declaration section is going to allocate memory for two variables, A and B. So what is the value of A? 3. Value of B is 2. Now it is going to print value of A and B. 3, 2 will be displayed. Now, similarly, next control is transferring back to the main function, and function F2 is called. So this is going to display A and B values, that is 3 and 2 again. Okay. So this is how the output contains 3, 2, 3, 2, and every function will be able to access those variable values. Every function will be able to access the global variables or variables under external storage class. Okay. So now we'll discuss about the other storage class that is remaining, which is register storage class. Okay. So in the register storage class, again we'll discuss about all these corresponding factors, okay, or properties of the register storage class, starting from storage area. First one is storage area, and the second one is what is the initial value. Okay, initial value, and also what is the keyword used for this particular register storage class. Okay, and then what is the scope and lifetime of this register storage class? Scope, the other one is lifetime. Okay. So first one is storage area. Okay. So what is meant by storage area? Okay. You can see where these variables that are declared under register storage class is stored. So as the name indicates, register storage class, obviously these variables are getting stored in the registers. So this you need to remember, register are the source of storage for the register storage class variables. Next one is initial value. So the initial value will be a garbage value, will be a garbage value. Okay. So next one is keyword. So keyword used is register. Register is the keyword used. Okay. So next one is the scope and lifetime. So the scope and lifetime of register storage class are basically just similar to the automatic storage class. Here also the scope of register storage class is accessible within the function only. Okay, accessible within the function. So if you consider lifetime, so again the lifetime is limited within the function. So once the control comes out of the function, you cannot access those variables. Okay, so scope and lifetime are accessible within the function only. Okay, so coming to example for the register storage class. Okay, consider this example, stdio.h. Let's include the header file first, and then in the main function I'm going to consider two variables which are under register storage class. Register A is equal to 5, B is equal to 3. Okay, okay, basically this is register int. Okay, obviously it will take integer data type, register int. Okay, so then you need to print A plus B. So just similar to the automatic storage class, here also you can see this is under register storage class. There are two variables, one is A, the other one is B. Okay, so value of A is currently 5, and value of b is currently 3. Okay, so finally it is going to display a plus b. So a plus b means 5 plus 3 value displayed will be 8. Okay, so this is how you will get the output as 8. So very simple, register storage class is as simple as automatic storage class. Only the difference is in the automatic storage class, those variables are basically stored in memory area, whereas here registers are used for storage purpose. Okay, so what is the advantage of register storage class? Why we are switching to registers? So register storage class corresponding advantage is storage in registers is faster. Okay, faster access purpose. You can access very fastly. But coming to disadvantages, here registers are always limited in number. You can't simply ask for 200 registers or 500 registers. Okay, so registers are always limited in number. Limited in number. Okay, and then again these registers you cannot use as part of pointers. Okay, so like for pointer variables you can't go for register storage class as pointers are always holding the address of a memory location. Okay, so you cannot apply pointers in register storage class, cannot apply or use pointers here. Okay, so these are the major disadvantages with the register storage class. But since these register storage class corresponding variables are faster to access, we generally use for loop variables. We generally use for loop variables in the register storage class. Okay, so loop variables are considered under register storage class so that you are going to access these loop variables frequently. Yes or no? When I write a for loop variable like I is going to be accessed frequently, right? So whenever you access frequently, if the same frequently accessed variable is stored under the register storage class, it will provide you better performance because the same register will be accessed again and again. As a register access is faster, so you can easily access it. Okay.
So next one is we need to write a program in order to find the factorial of the given number. Okay, for that purpose we have to write a function. So it's not recursive function, it's a non-recursive function. Okay, write a function to compute factorial of a given number, So in order to identify the factorial of the given number, first we have to write a function. Okay, so let's start writing the code. First include the header file. After including the header file, so now name of the function is fact. Okay, so return type is integer because after computing the factorial of the given number it is going to return a value. So int fact. Now consider the parameter as n. So this is the function where it is basically computing the factorial of the given number, and there will be a return statement here which is going to return the result, okay, back to the calling function. So this is a program structure for fact function. So now similarly you will see the main function where you will take value of the number, okay, so for which you are trying to find the factorial, okay. So here you can see int n. So printf statement, you can ask or prompt the user to enter any value, okay. So using scanf, you can read the value into the variable. Scanf percentage the address of n, okay. So now we can call this fact function by passing this parameter n, okay, just like this, fact of n, but this is going to return a value, right? Okay, so since the return type of the fact function is clearly integer data type, so you just need another variable or simply call here, okay, printf result is equal to percentage d. Now you can make a call to this fact function, fact of, and pass this n value here, okay, just like this. So now let's finish this fact function, which is going to return the factorial of the given value, okay. So for this I'm taking a loop variable int I, and also initial value of f, I'm considering it as 1, okay, because you need to iterate using for loop. For example, if you want to compute 4 factorial, it can be done as 1 into 2 into 3 into 4. So I'm using this particular logic here. So let's iterate using for loop. For I is equal to 1, okay, I less than or equal to n, I plus plus, okay. So the associated statement can be f is equal to f into I. So in every iteration you are taking a value and multiplying it with variable f. So finally you can return the result f, okay. F can be returned back to the calling function. So now let's see how this particular code is going to work. So in the output screen, you can clearly see enter any value. Enter any value. Suppose user has entered value as 4. Okay. Immediately it is going to call fact of 4. So value of 4 will be copied into variable n here, because this is the function, right? So n value will become 4. Okay. So you can see I is equal to 1, I less than or equal to n. So in every iteration you are going to multiply value of I with f, and initial value of f is how much? 1. So you can see here it is going to perform the same action, right? 1 into 2 into 3 into 4. So in the first iteration you will get 1. In the second iteration I is equal to 2, that is multiplied with f. In the third iteration 3 is multiplied. In the fourth iteration 4 is multiplied. So once I value reaches n, then the loop will be executed, and later immediately it is going to terminate the loop. Okay, I plus plus means I value becomes n plus 1, so which is 5 in this case. 5 less than or equal to 4, condition becomes false. So associated statement will not be executed, and it is going to return the value of f back to the calling function. So 1 into 2 into 3 into 4, value will be 24. So this value of 24 will be returned back to the calling function, and it will be displayed exactly in this position. Okay, so you can say the result is equal to 24. Okay, so this is how it is going to produce the output here. Okay, so now we'll see another program. related to function calling only. Okay, so here next program is we need to find Fibonacci sequence with help of function calling. So it's not recursion, it's purely function implementation. Okay, so implement a function, implement a function to display nth term in Fibonacci sequence. So in the entire Fibonacci sequence, we are trying to display the nth term, whatever value of n it is passing based on that. Okay. So now let's include the header file first of all. Now write the name of the function. Okay. So since you're trying to return the value, or if you want to display there itself, you can also display. For example, if you're displaying in the function itself, then the return type will be void. Okay. So name of the function is fib, and it is taking nth term to display into Fibonacci sequence. Okay. So now, in order to display nth term in the Fibonacci sequence, first you need to consider here if the nth term is equal to 0, which means if you're trying to display the 0th term. Okay. So in that case, or if you want to name it as first term, n equal to 1, then you can directly print here. Okay. Printf percentage d. Okay. So here you can take variables like a is equal to 0 and b is equal to 1, and c you need to compute here. Okay. So n equal to 1 means you are trying to print the first term in the sequence. Value of a needs to be displayed. Now, else if nth term is second term, then you can directly print the second term, which is b here. Okay. So in the else block, now you can implement the corresponding term to be implemented, right? So you need to implement code in order to display the corresponding term. So first of all, you take another integer variable called I. Okay. So now you can iterate using for loop. For I is equal to, you can see first term and second term. So they have already printed. If you are asking for the first term, it will be printed here. If you're asking for second term, it will be printed. Now I is equal to 3, I less than or equal to n, and then I plus plus. Okay. So now we can perform the corresponding action, isn't it? So we need to iterate these many number of times every time. So you just need to remember that a is equal to b. Okay. And then b is equal to c. And then c is equal to a plus b. So in every iteration, value of a and b will be modified, and hence value of c also gets modified. So finally, in the nth iteration, whatever value of c that is obtained, that will be displayed. Okay. So finally, you have to display here printf percentage d, the corresponding c value. Okay, so this is how we can write the entire Fibonacci sequence corresponding code. Okay, so now let us suppose you're calling the main function. Okay, in the main function, suppose we take n as a variable. Okay, so n is representing the nth term in the Fibonacci sequence, right? So printf asks the user to enter the term. Okay, enter term in fib sequence. Okay, so then the user will be entering that particular term, and you can read that term into a variable called n. Okay, then immediately you can call this particular function fib. Okay, so simply call this function fib by passing the parameter n. That's it, task is done. Okay, so you can see here clearly, suppose the user is sending a value of n, okay, as 3. Clear? So consider n value that is passed here is 3. N value is 3. Now you're passing fib of 3, isn't it? Then value of 3 will be copied into a variable called n. Okay. Now a is equal to 0, b is equal to 1. So you can see n double equal to 1, 3 double equal to 1. Condition becomes false. So now it will go for the else if block. N double equal to 2. So 3 double equal to 2. Condition becomes false. So it will go to the else block. I is equal to 3. Yes, I equal to 3 and 3 less than or equal to 3. Condition true. So only one time this for loop will be executed now. A is equal to B. Okay. So A is equal to B means A value is 1. And then B is equal to C. So very simple, in the else block, okay, you should be computing first C is equal to A plus B here. Okay. So B is equal to, by the time C is equal to A plus B is executed, you can see 0 plus 1 value becomes 1. So B value will also be 1. Now C is equal to A plus B. 1 plus 1 value will become 2. Okay. So in the next iteration, I value will become 4, and 4 less than or equal to 3 condition becomes false. So this time it will not enter into the for loop, and the latest value of C will be 2. And it is going to print a C value. So in the output, the nth term in the Fibonacci sequence is 2. So where n equal to 3. We can observe the Fibonacci sequence 0, 1, 1. Okay, next term is 2. Yes or no? So you can see the term like this 0, 1, 2, 3. Isn't it? Clear? Just like this.